Warm-up 27, power standard number 3. Real-world problems, and this one involves systems. Lisa is making mittens to sell at a craft show in the fall. Lisa pays $51 for the booth and $2 for the yarn for each pair of mittens. If she sells the mittens for $5, how many pairs of mittens must she sell for the expenditures to equal the money made? Write and solve a system of equations. Okay, so if we talk about expenditures, we're saying that, I'm going to say maybe C for her cost, is going to equal $51 plus $2 for yarn for each pair. Maybe I shouldn't use Y there, but you can use any variable. Now, we want to know how many she can sell for $5. So let me actually change this to just 2Y to 2M. So it's actually $2 per mitten. That makes it a little bit easier. So again, the total cost here is going to be, she's going to make $5 per pair of mittens. So what we want to do is we want to know when these two things equal each other. So I can take 51 plus 2M, $2 per mitten, plus 51 total dollars, and we want to know when that is going to equal how much money she brings in by selling each pair of mittens for $5. So variables on both sides, remember when there's variables on both sides, we want to combine them onto one side by getting rid of them on one side. So I'm going to get rid of the 2 mittens over here, 2M, and whatever I do to one side I have to do the other. That cancels out. I'm left with 51 equals 3M. Divide both sides by 3. And the number of mittens she needs to sell needs to be 17, because 51 divided by 3, I believe, is 17. So if you go back to make sure you're answering the question being asked, it says, if she sells each pair of mittens for $5, how many pairs of mittens must she sell? She must sell 17 pairs of mittens. And that's just the way, because it wanted us to write and solve a system. That's the way of doing it, writing and solving a system. Okay. Power standard 4, using coordinates. The point 2, -3 is reflected over the x-axis. This is the y-axis. This is the x-axis, so we have to make sure we're doing the correct one. And when we're reflecting, we're creating a mirror image. So if I wanted to create a mirror image over this line, it's going to be the same distance away. So if I'm 3 units below, I need to be 3 units above. And that would be at the point 2, +3. So when you notice, our x value stayed the same. It was our y value that changed. So if we wanted the coordinate notation for it, we would say we take our point, and our x stays the same, but then our y becomes its opposite. We went from -3 to +3, and that would be the coordinate notation for reflecting over the x-axis.